Today we're going to be talking about distribution with radicals. So here's our first problem. It's the square root of 7 times 3 minus the square root of 7. First thing we want to do is distribute. We have a pair of 7s now. That comes out, and there we go. Next, we want to do the same thing. We want to distribute. Put them both under the radical, and we break them down. We simplify, and we're done. Can we put 2 square roots of 3 plus 2 square roots of 5 together? No, because they're not like terms. The next one, this is an exponent of 2, so it's raised to the power of 2. Don't forget, you have to write it twice. Now we're going to distribute. Many of you use the box method, and some of you use FOIL. Once we do this, we can see that our center terms are like terms. We're going to combine the like terms. And are we done? No, we can simplify some more. 16 and 75. Voila, here's the final answer. One more. We're going to use the box method or FOIL, or you can say distribute twice. I like that last term, the square root of 3 times the square root of 3, because it definitely will come out. And we always want to simplify in each step. Here, if you notice, the middle terms, positive square root of 15 minus the square root of 15 cancels out, and 5 minus 3 is 2. Hopefully you noticed when you first looked at this problem that it was like the difference of 2 squares. So we have the same terms, one with a plus and one with a minus, so we definitely expect that middle term to cancel out. All right, we're going to talk about rationalizing with conjugates. So if you have an a plus b times a minus b, definitely remember that that is a squared minus b squared. So anytime you have in your factored form the same terms with a different sign, our vocabulary for that is conjugates. Once we FOIL it out, this is what we get, and clearly the middle terms cancel out. So, when do I need a conjugate? When there is at least one radical in the denominator which is added or subtracted with another term. So let's take a look. So let's look at the first one. Yes, we need a conjugate because we have a number minus a radical. Here we don't need a conjugate. We can just rationalize, multiply by the square root of 5 so it can come out. Here, no conjugate needed. Here we have 2 terms being added. We definitely need a conjugate. Definitely a conjugate. Not a conjugate, not a conjugate, need a conjugate. All right. So let's get started. This problem, we definitely need a conjugate. As you can see, in the radical, we have in the denominator, we have a radical. It is 2 minus the square root of 7. So 2 subtract the square root of 7. Definitely need to get rid of the radical. Definitely going to multiply by a conjugate because we definitely need the middle terms to cancel. So what we're going to do is we're going to multiply the top and the bottom of the fraction by the conjugate of the denominator, because of the properties of equality in math. Right? If it helps, you may want to put parentheses around your terms, your binomials. I have it color coordinated, but basically you need to see that it is the distributive property, 5 times 2, and then 5 times the square root of 7. So in my numerator, I get 10 plus 5 times the square root of 7. What I expect in my denominator is the middle terms to cancel out. So check it out. Once those middle terms cancel out, and we simplify, we get at the top 10 plus 5 times the square root of 7. But now in our denominator we have 4, and on the end we have minus 7. We can simplify. This is 10 plus 5 square root of 7 over 3. We've gotten rid of the radical in the denominator, and this is completely simplified. If we wanted to rewrite it without the subtraction in the bottom, we can put it on the side, and then here it is again. I won't take off if you have it either of these ways. All right, so we're going to try these. We can look at each one, look at the denominator, and we see, we need a conjugate for each one. So the conjugate is going to be the same numbers or the same terms with a different sign in between. So let's take a look at this first one. So in our first one, the denominator is square root of 5 plus 9. So our conjugate is going to be the square root of 5 minus 9. We multiply the top and the bottom, and then we're going to distribute at the top and FOIL at the bottom. After that, we simplify. And once we simplify, this is what we get. 3 times the square root of 5 minus 27 all over negative 76. Let's take a look at the next one. It is the square root of 2 plus the square root of 5. The conjugate is going to be the square root of 2 minus the square root of 5. We multiply the bottom and the top because of the property of equality. And here we go. We're going to distribute and simplify. Let's take a look at problem number 4. We see the denominator, and it's definitely in need of a conjugate. Square root of 3 minus 3, what would the conjugate be? Hopefully you said the square root of 3 plus 3. We multiply the top and the bottom by the square root of 3 plus 3. We have to FOIL now. So we have 2 terms at the top and 2 terms at the bottom. We'll multiply the first terms together. 8 times the square root of 3 gives us 8 times the square root of 3. 8 times 3 is 24. Square root of 10 times the square root of 3, square root of 30. And the square root of 3, the square root of 10 times 3 is 3 times the square root of 10. We take a look at the denominator, the conjugate. We know what we want to happen. Voila. Can we simplify this even further? Can I break down 30? I can break down 30, but I won't get a perfect square out of it. So we have to leave it like that. So this is using conjugates to get rid of the radical in the denominator.